So today we're continuing on from what we were doing in 4.4, kind of, but now it's the other way around. So now we're being given information and we want to plot the graph. So that's great, which we can do. So if I see, so for here, this first one, I've got find the y-intercept and gradient, and then sketch the graph of the equation y equals 4x plus 1. Okay, so straight away, without doing anything else, if I see y equals 4x plus 1, what are some pieces of information I can immediately know from seeing that? Yep, and the gradient, right. So the y-intercept, that's great because that means that I have a place I can start drawing my line from. And the great thing about linear equations is you only need 2 points. You join up those 2 points and then, you know, rule through the start and finish and it's all done. Okay, so what was my y-intercept here? 1? Yep. All got it. So I'm going to put a dot there on the 1. Oh, yep. Good question. So if I'm looking at my equation here, y is the y-intercept 1. Yeah, so c. So the 1 is the c. The other way of thinking about it is the y-intercept always occurs at what value of x? 0. So if I take my equation here and I go y equals 4 times 0 plus 1, then what does y equal? 4 times 0 plus 1, that goes to nothing and I just get y equals 1. And so that tells me when x equals 0, y equals 1, and so I have my y-intercept. So I put my dot there at y equals 1, and now I don't really know much else other than the gradient. What do I know about the gradient in that equation? It's 4 over 1, yeah, essentially. So if we're thinking rise over run, so remember gradient, oops, okay, get used to this new pen, here we go. M is equal to rise over run. In this case, it's 4. And so if 4 equals rise over run, then it must be 4 equals 4 over 1. 4 over 1, that's all fine. 4 divided by 1 is still 4, so that's okay. And it's always the coefficient of x here when the coefficient of y is positive 1. Remember coefficient, the number that goes in front of whatever these letters are. So I've got it in the shape, I guess, or in the format of y equals blah, and whatever is in front of the x, even if it's a fraction or if it's a whole number, that's great. Okay, so what's that telling me? My gradient is 4, which means there's a rise by 4 and a run by 1. And then what happens? Sorry? Yep, say it again. Up 4 and across 1. That's exactly it. So I'm literally going to go there. I'm going to go up 4, 1, 2, 3, 4, and across 1. And there's my second point. So 1, 2, 3, 4, across 1. I now have 2 points, and that's all I need for a linear equation or a linear graph. And I can use my ruler to try and line up between those 2 points. Yep. So yeah. So I can use that equation. I can use the y-intercept as a starting point, and then go great. From that point, my gradient is pretty steep. It's 4 over 1. So if I count up 4 to 2, 3, 4, 5, and then across by 1, that's where the next point is going to be. And I could keep doing that, except that the graph's not big enough. But I can do it on the bottom side, I think. Okay. So if going left to right is that direction, then going right to left, what would be the opposite of that? Going down by 4 and then left by 1. So 1, 2, 3, 4. Oh, look at that. It passes through that point. Yay. Celebrations. Okay. So that's essentially an indication to us that we've done it correctly. Yep, sure. So that's it, really. I was just using the y-intercept as a starting point and the gradient to count how many either up or down and then to the right. Yeah? Unless it's a fraction. Yeah, correct. Yeah, whenever it's a whole number, your run is 1. That's a good point. This graph obviously doesn't stop there and doesn't stop there either, continues on, but we can just represent that from arrows. That's fine. Otherwise we could be drawing lines forever, which we tend to do for a little while. Any questions about that first one? Nope. Yeah, sure. Yeah, okay, we'll leave it there. Oops. Put my I don't know how to stop it now. Oh, there it is. Pause. Okay. Um, now the next one hasn't been given. So the first one they gave it to us in a very simple format. And in fact, the easiest format just to see immediately, just looking at it. Oh yeah, my y-intercept is 1 and my gradient is 4. In the next one, they give us an equation that we're going to have to rearrange first. So they've given it to us in the form of ax plus by, whatever. So 3x plus 2y equals 4. And I can rearrange that. And what do I essentially want to get on its own? I want to get y on its own, yeah, with a coefficient of positive 1. So I'm going to rearrange that in order to get that. So it would be a mistake for me to think that the gradient was, what, 3. So the coefficient of x right now is 3, but that's not the gradient because it's on the same side as y for starters. And then secondly, it's y has a coefficient of 2 instead of positive 1. So I'm going to move things around. I'm going to go 2y must be equal to 4 minus 3x. And you could write it as negative 3x plus 4. Either way is fine. And now I just want to get rid of that 2. So y equals 2 minus 3 on 2x. Or 3x on 2. Now remembering that positive and negative numbers are defined by the sign that's in front of them. So what is my y-intercept here? And remember the y-intercept is the constant. 2, yeah, just positive 2. Y-intercept's positive 2. It's 2, and what's my gradient? Remember the gradient is always the coefficient of x. Very close. It is 3 over 2. Yeah, so 1.5, but it's a minus. So it's a negative. So I've got 2 minus 3 over 2x. So my gradient there must be negative 3 over 2. And if I make that similar to rise over run, then what's my rise going to be? Minus 3. And my run would have to be 2. Yeah. So where am I going to start off in this graph? Sorry? Yeah, let's start off at the y-intercept. And what is the y-intercept? 2. So I'll start off at 2. And then I know by my gradient that I'm rising by, oh, sorry, I just want to access something here. Just to shrink this a bit. That's great. I'm rising by how much? Minus 3. So technically I'm going down by 3. So 1, 2, 3, and running by 2. So there's my next point. If I were to label that as a coordinate point, what would I call it? Or sorry, label it, like what would the points be? 2, negative 1. Yeah, x comes first, y comes next. So now I've got those 2 points there. And just a simple matter of doing that thing again. Line it up, draw the line. Doesn't have to be go across the whole thing, it's fine. But yeah. Now, for that equation, for the original one or the y equals mx plus c format, whatever value of x I put in, the y value should correspond to that. So if I put in x equals 4, y should be equal to negative 4, and so on and so forth. Make it true. Any questions? No. So really, it's very similar to the one before. It's just a matter of rearranging at the start. Can I move on from there, or should I leave it there for a sec? Yeah, sure. The last one Sketch the graph y equals 3x showing the y-intercept and one other point. Not too bad. What is the y-intercept here? On y equals 3x, 0. So effectively, if I was comparing that y equals 3x and I was equating that to y equals mx plus c, then my m is clearly 3 and my c is clearly nothing. 0. It's not there. So where should I start from? Yeah, let's start from 0. I can start from there. My gradient is what? 3 over 1. So I'm going to go up by 3, up to 3, and across by 1. I have my second point. Done. Ta-da! And drawing the line there. That works. Have I answered the question? It says sketch the graph of that, showing the y-intercept and one other point. Yeah, I've done that. I can even label this if I want to, 1, 3. And this is obviously 0, 0. Any questions? Nothing? Yeah. I'll leave that there.